Lawful Intercept, or LI, is for operators to send certain voice and data communications to a remote law enforcement agency, or LEA, for possible monitoring and recording. In Turks and Caicos, there is no legal requirement for operators to implement LI. Because LI does not earn the operator any revenue, LI is not implemented unless required by law. This training module takes examples from the PLMN, but the information is equally applicable to PSTN and ISP networks. LI can be used as a weapon against terrorism, pedophilia rings, cyberstalking, data theft, industrial espionage, and drug dealers on the internet. Some people object to LI for reason of breach of privacy and security. Because of the sensitive nature of LI, vendor engineers responsible for its design and implementation must normally sign a non-disclosure agreement. The LEA is responsible for defining the LI's monitoring specifications. Operators are legally obliged to comply with these and forward them onto their core network vendor. LI must be implemented in such a way that the interception is on the targeted subject only, that the subject is never aware of the interception, and that the service of other users is not affected. The increasing use of mobile and VoIP technology has meant that it is no longer possible to guarantee an intercept call by tapping a physical circuit. Instead, MS-ISDN, IMSI, IP addresses, logins, ports, routes or text, etc. may be the target. Types of traffic that may be intercepted include voice, surfing the World Wide Web, email, SMS, chat, and FTP. Even encrypted versions of these, as LEAs normally have the applicable encryption keys. LI traffic dimensioning specifications are based upon the number of simultaneous call interceptions that can be made from CS and PS domain targets. Also specified is the number of LEA networks and the traffic distribution between them. The dimensioning is performed per operator and will vary according to how many subscribers are connected to each operator. LI deals with two products. These are contents of communication such as voice, video, images or messages. Intercept-related information refers to the signaling information, the source and destination of the call. Whenever a new target is provisioned, a warrant ID and case ID assigned by the LEA is required. Each case may require intercept-related information, contents of communications or both to be intercepted. Each task is assigned a start date and an end date upon which the case will expire. The functionality of LI can be divided into three main groups. Inside the operator's network, the transmission between the operator and the LEA, and inside the LEA network. The vendor of the operator's core network usually supplies the LI equipment for inside the operator's network. If an operator has a multi-vendor core network, LI equipment per core vendor is required. The LI equipment in the core can further be split into three logical function groups. The relationship between the functional group and its physical entity can be different for each vendor. The first of the groups is called IIF, or Internal Intercept Function. This is software that is installed within the nodes in the network that carry the content of communication, for example voice, video or message. An example of a node that would have IIF installed in a mobile network would be the media gateway. The second group is the Intercept Management System and must only be accessed by authorized users. It manages the deployment of intercept tasks to the other CS and PS nodes with IIF installed. The Intercept Management System is also responsible for making sure its target lists matches those in the IIFs. Any differences are automatically reconciled. The last group is the mediation function. It is the interface between the operator and the LEA for both contents of communications and intercept-related information. The mediation function normally communicates with the IIF installed elements using a proprietary protocol. This is why the mediation function cannot communicate with IIF elements from a different vendor. The mediation function must be configured so that its interface to the LEA is compatible with the required standard output. The LEA network is not normally co-located with the operators, as the LEA will monitor all of the networks in Turks and Caicos if implemented in the future. Transmission between the operator's mediation function and the LEA is normally using E1 transmission over copper, fiber or microwave. This is because a large number of monitored traffic is not the norm and is not expected. The intercept management system encrypts essential target information. Any information stored in the IIF is an encoded form and thereby prevents unauthorized access to sensitive warrant information. Any information stored within the IIF is stored in volatile memory, so that this information is erased if a component of the network node is removed or powered down. Only the encrypted database of the IMS should be maintained during power down situations. In the event of a link failure between the mediation function and the LEA, the intercept products may be buffered for a short time in memory only. Any long-term failure of the interface will result in the intercept products being lost. This information must not be spooled to permanent storage. The LEA network is composed of 4 basic logical layers. The collection layer receives intercepted communications via the transmission from the operator's mediation function. The storage layer is composed of online storage components and offline storage components such as the evidence server that creates archiving on DVDs. For security purposes, the user workstations should not have direct access to the storage layer. An application gateway server should carry all database operations on behalf of the users. The application and processing layer is used for indexing, searching, location tracking, free test search and data decoding. This will allow, for instance, an alert to be displayed when a target enters a particular area or sends a message with predetermined words or participants. The operations layer is used for system administrator and the health monitoring applications. The LEA is required to manage the interface with the network elements, distinguish among many formats and layers of voice and data communications, and processes each type of communication and protocol. It also has to provide the storage for the intercepted traffic, as well as the functions of online monitoring, location tracking, offline viewing, and searching and producing legal evidence records. The service should cover the whole network. There is a logical demarcation point between the operator's network and the LEA network. The interfaces between the two networks have been standardized as handover interfaces HI1, HI2 and HI3. HI1 carries the request from the LEA to provision targeted traffic. HI2 carries the intercept-related information. Both HI1 and HI2 use TCP/IP towards the LEA. HI3 carries the contents of communication. It uses TDM towards the LEA. As TCP/IP and TDM cannot share the same E1, normally a minimum of 2 E1s are configured between an operator and each LEA. Currently, the government of Turks and Caicos do not legally oblige the operators to implement LI. However, as more and more governments globally do enforce the use of LI, this may change in the future. For operators, LI is an expense, even more so if they deploy a multi-vendor network. For this reason alone, the operators will never welcome LI.